Okay, so this is part 2 of lesson 32.2 video, solving quadratic equations. We were ready for task 3, I believe it was, where our a value is not 1. So this step 1 now is just going to be a little bit more intricate, because if you notice, the form that we're supposed to get this into involves an a value of 1. So that will just involve, like I said, just a little extra step, and I'll show you how to do that. It's not bad. So we're just going to follow our steps. First thing I have to do is get this into the correct format. So I'm going to have to add 2 to both sides to get my c value over here. I'm actually going to shift my work over here just in case I need like 2 columns that all have that space. So I have 3x squared minus a 5x equals 2. And then I need to get this a value down to 1. So basically, if I divide this whole thing by a 3, that will take that a value to a 1. So now I have x squared minus, I'm just going to leave that as a fraction when I divide by 3, and I'm going to leave this 2 as a fraction when I divide it by 3 as 2/3. Okay, so now I have x squared minus 5/3 x equals 2/3, and I'm going to continue to follow my steps. My next step is to find that b over 2 squared. Do that out to the side here. So my b is a negative 5/3, and I'm supposed to divide it by 2, or I can multiply it by 1/2 because it's the same thing, and then square it. So there's my b over 2 squared. So that's going to give me negative 5 over 6 squared, which means I'm adding 25/36 to both sides. So I'm going to add 25/36 here. I'm going to add it here. Of course, I need common denominators to add my fractions. So to get this 3 to a 36 denominator, I'm going to multiply by 12, which would give me 24/36 when I add. So I'm left with x squared minus 5/3 x plus the 25/36 equals, and when I add this, you get 49/36. Those are both perfect squares. So this is going to look somewhat simple when we're finished with it. It's not going to be too messy, which is good news. Okay, so now I'm ready to factor. Remember, my 2 binomials should be exactly the same. So of course, x times x gives me my x squared. Square root of 25/36 gives me 5/6. But in order for them to add and be negative, I know that they're going to have to be a negative 5/6. I'm ready to square root both sides. Of course, what I do to one side, I have to do to the other. So I end up with x minus 5/6 equals plus or minus, the square root of 49 is 7, the square root of 36 is 6. So it's plus or minus 7/6. So I'm going to have 2 equations that I am solving, setting up and solving. My 2 equations I'll set up over here. X minus 5/6 equals a positive 7/6, and x minus 5/6 equals a negative 7/6. So when I add my 5/6 to both sides, I get 12/6 here, or 2. So that came out nice and pretty. And then over here, I'm going to add my 5/6, which is just going to give me a negative 2/6 or a negative 1/3. So those actually came out pretty nice, simple numbers. Of course, whenever you're dealing with the math that has all of these, negatives and positives and fractions and steps, and, the process is kind of lengthy. If you do have access to a graphing calculator, it probably wouldn't hurt just to plug it into your Desmos graphing calculator and confirm your zeros or your roots as a positive 2 and a negative 1/3 or a negative 0.3 repeating. So here's my positive 2, here's my negative 1/3, entered or shown as a decimal, which is equivalent. So we know that we did that correctly. As our graph here, Desmos has graphed it for us, and we can see that fairly easily. All right, Well, that one was pretty intense. So pause the video and try number 7. Remember, if you try on a separate piece of paper, that's fine, but you do want to try to go as far as you can. Even if you make a simple error, that's part of the learning process. So please just pause the video, give it a try. Okay, so I didn't do too much without you, but because of time, I wanted to jump ahead just a little bit. So basically, I subtracted my 9 to get this in the correct format, and then I had to get rid of this a value. I wanted an a value of 1, so I had to divide everything by 4. When I did that, I ended up with t squared minus 1t equals negative 9/4. Of course, when I divided by 4 here, I left it as a fraction, but the rest of these came out pretty integers. Then I calculated my b over 2 squared, and I got 1/4, so I'm about to add that to both sides. I am ready to factor, so t minus something and t minus something give me negative 8/4. The square root of 1/4 is 1/2, so it'd have to be a 1/2 and a 1/2, because when multiplied they equal positive 1/4, but when added they equal negative 1. So I'm ready to square root. And right here, I know that something's not right, because of course I can square root this side, which would just give me t minus 1/2, but I notice over here, I can't square root a negative. So as soon as I see that square root of negative, I know that this is a no solution. So think about what that would mean for your parabola itself. Oh, that didn't turn out as pretty as I wanted it to. Sorry about that. No solution. There we go. It's better when you can kind of read it. Think about what that would mean for your parabola. Your solutions of your quadratic are your x-intercepts. So what is happening to a parabola that opens upward and doesn't ever touch the x-axis? So, let's look at Desmos to confirm our answer here. And as you can see, here's my vertex, and this parabola opens upward. So it's not ever going to, curve back around and come back down and touch this x-axis. So this is in fact a no solution, and solving by completing the square showed us that pretty easily as soon as we got to square rooting this negative. All right, ready for number 8. Again, pause the video, try the first couple steps on your own if you can, and then we'll bring it back together to talk about it. So I have to get this in the correct format. I'm going to subtract 4 from each side. Giving me a minus 4. Divide by 3 to everything to get this in the correct format. So that gives me an x squared minus, I'm going to leave this as fractions again, negative 4/3. Ready to calculate my b over 2. So there's my b. Dividing by 2 is the same as multiplying by 1/2 squared. So I have negative 8 over 6 squared. I have to add that to both sides. So I'm adding 64/36 to both sides. And that's going to give me let's find our common denominator over here. So multiplying by what, 12 to get this to 36. So multiplying by 12 would give me 48 here. 36 there. Now I'm ready to add my 64 and my negative 48. Give me 16 out of 36, a positive 16 out of 36. Those are both perfect squares, so that's looking pretty good. This one might not come out too messy. let's go ahead and factor. It's going to be x minus 8/6. Oops. And of course the same thing again. Because when I multiply those, it takes me back to 64/36, but when I add them together, it would take me to negative 8/3. Ready to square root. That would give me the positive and negative 4/6. And then I need to set up and solve my two equations. So that's going to be x minus 8/6 equals a positive 4/6. X minus 8/6 equals a negative 4/6. Equals, there we go. I'm going to do the math to get my x by itself, which means I'm adding 8/6. Give me 12/6 over here, or positive 2. Adding 8/6 over here, which would give me a 4/6 or a 2/3. And then of course we can confirm that with Desmos. So here is my 2/3 as a fraction, or as a decimal, excuse me, which is equivalent to 2/3, and then my positive 2. So 2/3 and 2. 2/3 and 2 were the answers that we got, so we did that correctly. All right, when ready, we're ready for the final problem. Go ahead and pause the video and read this to yourself. It says an architect designs a rectangular room with an area of 400 feet square. The length is to be 8 feet longer than the width. Find the dimensions of the room and round your answer to the nearest tenth of a foot. So again, pause the video and try to draw a picture to represent this to help us better understand. Okay, so I know my area of this rectangle is 400, and I know that area is length times width. It tells me that my length has to be my width plus 8, because it's 8 feet longer. So if W is my width, then my length would be W plus 8. So again, I know that area is length times width. I'm going to substitute what I know, use substitution. My length is W plus 8 in parentheses. Ooh, this is not looking good. Sorry, guys. Length in parentheses, W plus 8, and then my width. So my area, which is 400, I can plug that in as well, and then I can distribute this. Trying to get this as simple as I can. I can use completing the square here to solve this, and if you want to write it kind of like our others, you might look a little bit more familiar like this with the 400 on the right side. But go ahead and pause the video, see if you can use the completing the square to solve this. Okay, so I went ahead and calculated my b over 2 squared and added that to both sides. That gave me my perfect square trinomial over here and gave me 416 on this side. I factored and square rooted both sides. At that point, I did go ahead and take my answer down to a decimal when I square rooted, because it does ask me to round my answer to decimal place here. So when I did that, I got 20.396. Of course, I have to subtract 4 from both sides, which gave me a width of 16.4. And then don't forget, we know our length is 8 longer than that. So I'm going to have to take that and I'm going to have to add 8 to it, which gives me 24.4. And that is going to be, I believe, in feet. And we are finished. Good timing. All right. That concludes your video for completing the square.